Good afternoon. Let's get started again. Welcome to our first afternoon panel on measuring data use and personalization. We'll start out with presentations by our three panelists, all of whom are computer science professors. And we'll start out with Anupam Datta, who is a professor at Carnegie Mellon University.
Thank you, Ed. Julia's talk was an excellent segue into this panel. The question that she raised about how to provide due process is what I want to talk about now. In particular, our goal here is to develop computational tools that can help provide both internal and external oversight on the data handling practices of organizations that handle large volumes of personal information. So the setting here of information of what we call information flow experiments is imagine a user who interacts with the web and their browsing history is known to providers who serve ads. And the question is, does this browsing history affect the ads that are being served? This is a question of information flow, which means does changing the inputs, does changing browsing history affect the probability distribution of ads? Information flow is a very well-studied problem in computer security for the last 3 decades or so. The new challenge here is that the analysis is here being done by analysts on the outside who don't have access to the source code and the data models that are being used inside of companies like Google. And in addition, there are a lot of other confounding inputs. In addition to my interactions with Google, there are hundreds of millions of other users who are also interacting with Google. And so when I see a difference in the ads that are being served to me, it's not clear whether the difference is being caused by my browsing history or because of the interactions of all these other users who are interacting with Google. So ideally, what I'd like to know is whether my browsing history is causing a change in the ads that are being served. And we have a technical result showing that our notion of information flow coincides with a standard notion of causation developed by Julia Pearl. And this requires careful design of the experiments and a careful statistical analysis methodology to ensure rigor in the findings. So I won't get into the details of the technical results and instead focus on some experiments that we did on Google's personalized ad settings. Many of you are familiar with Google's ad settings, but here's a quick overview. On the right, you see some of the characteristics that are going to be used by Google to serve ads to you. So this is the setting where this particular user is female, the age range is between 25 and 34, this person is interested in adoption and a bunch of other things. And these interests are things that you can yourself provide to Google, or these are things that Google might infer based on your browsing history, your search terms, and so forth. And we wanted to study how well the ad settings, it's a transparency mechanism, we wanted to study how well the ad settings are harmonized with the ads that you actually receive. So one way to think about what's going on here is that based on your browsing history, Google and this ad ecosystem has some internal state about who you are, what you're interested in, and so forth, which they use to serve ads to you. And some of that internal state is also reflected through this ad settings page. And the question, part of the question is how well harmonized they are. There are also questions about discrimination. Are you getting ads that might be discriminatory? So we have a tool and a methodology for Ad Fisher that we call the tool Ad Fisher. And the main thing I want to emphasize about this tool is that we can discover causal effects, and there is a really rigorous statistical analysis backing it up. So let me report on 2 experimental results. So this was a study that we did trying to understand discrimination. We divided up, we created these simulated users half of whom were randomly assigned to the experimental group, and the other half was randomly assigned to the control group. Both sets of users visited job-related websites, trying to send a signal to Google that they are interested in jobs. The only difference between the two groups was the gender bit. So the experimental group had the gender bit set to male, the control group had the gender bit set to female. And then both groups visited a third-party website and collected ads. So the first thing we wanted to study is whether these ad distributions that were served to the two different groups, who differed just in gender, were different. And we found that that was the case, and this was a statistically significant difference. It didn't just happen by, it's very unlikely that this difference happened just by chance. The next thing we looked at is what were the top jobs that were being, ads that were being served to the male and female groups, and we found that the top two ads that were being served to the male group had this promise of helping you find 200K plus jobs. Now this gave us pause because this was statistically significant effect, showing that gender was causing a certain kind of seemingly discriminatory ad to be served. Now there can be two possible reasons, at least two possible reasons for why this was happening. It could be that the advertiser was targeting this job to this particular demographic, which is concerning. Another possibility is that the machine learning algorithms which optimize how ads are being served found out over time that men tended to click more on these ads rather than women, and then they optimized how these ads were being served. In which case we have a problem with the machine learning algorithm. It requires development of new classes of machine learning algorithms that are aware of and cognizant of and are resistant to discrimination. The second experiment that I want to report on is a study of transparency, how well the ad settings reflect the ads that are being served. So very similar experiment. Now the experimental group visited the top 100 substance abuse websites, indicating to Google that they were interested in substance abuse. The control group simply idles, and then they visited a Times of India, the third-party website, and collected ads. As before, there was a significant difference in the distribution of ads that were served to the two groups. However, there was absolutely no difference in the ad settings page. So this was a case of where there was differential treatment, but the transparency mechanism which reflects, or is intended to reflect, that there was something that was inferred about maybe interest in substance abuse, did not show this difference. And this was a statistically significant result. We repeated the result for other topics like disability, and in some cases, in our other studies, we didn't find any statistically significant effects. Now, just to delve a little deeper into what the form of difference was, if you look at the top 3 ads that were being served to the substance abuse group, there were ads for the Watershed Rehab, which was a drug and alcohol rehabilitation center, which was clearly targeting people with substance abuse problems. So this again gave us pause. I don't know why this is happening, but this is something that requires a deeper investigation. So let me conclude with a few comments. There is a great need now for development of these kinds of computational tools that have well-founded methodology and that scale. This connection between information flow and causation is very important in this black box setting where there is so many different confounding factors. And we also need careful statistical analysis, otherwise we will end up with conclusions that are just not true. Scalable data collection and analysis is also hugely important, and this is an area in which we will hear more from the next panelist about other projects going on at Columbia, or we'll talk about some work at Princeton also on this topic. The second thing I want to point out is that often there is a huge gap between the privacy policies or promises that are being made by various websites and the principles that we may want to be embodied in these policies, like transparency, like non-discrimination. And we need some efforts to incentivize organizations to adopt these policies. The third thing, which is a direct consequence of these results about non-transparency or discrimination is, in many cases, these may be caused because the machine learning algorithms are just optimizing for click-through rates, and we need new classes of machine learning algorithms that are aware of concepts like non-discrimination and transparency. There is some activity already in the computer science community on this topic. There will be a workshop at NIPS later this year that Solon here and Moritz Hart are organizing, that Ed Felton and I and Cynthia Dwork and a number of other people will be speaking at. And finally, I think it's very important to have some mediums for effective interaction between academia and regulatory agencies and policymakers and industry. And some other projects that we have done in the past, we have had successful interaction and transition of privacy protecting tools to Microsoft. And this conversation, and this came up earlier in the morning, we need to be inclusive in our conversations and take the points of view of a number of other players. Thank you very much.
Nick, do you want to? Thanks. Our second panelist is Professor Nick Feimster from Georgia Tech.
The work that I'm going to talk about today was done with some other collaborators who deserve some mention. In particular, PhD student Sinyu Singh is behind a lot of what you'll see. Also, we've been doing this with Alex Snoren, professor at UCSD, and Wenki Lee, who's also at Georgia Tech. We've heard a lot today about personalization, and a little bit today about how personalization can act as a filter. Where online personalization can create situations where we may only see things that already suit our own tastes. This can turn up in search, social networking, e-commerce, entertainment, and so forth. Personalization actually can also be exploited. So this filter bubble that we heard allusions to earlier, I'm going to basically show you as a best case scenario. My talk is about something that we call pollution attacks. The idea behind a pollution attack is that a recommender system gives you some outputs, be that search results, recommended products, so on and so forth, based on certain inputs, where the inputs are the types of things that we've been talking about that people like to track. So personalized search is one place where this type of recommender system shows up. Video and product recommendation is another, and ad networks are another. What if the inputs could be polluted? Turns out, actually, that's possible. But let me first describe to you what might happen. So Bob's browsing behaviors typically, and other things, but in particular, we're talking about the browsing behaviors for this talk, make up some part of his profile. And some recommender system basically uses that information to serve, let's just call it relevant content, because as we're about to see, it can get much worse. Let's suppose that some kind of attacker can pollute Bob's profile. Then what might happen is that instead of getting things that are at least vaguely relevant to Bob, Bob might actually see content that somebody else, in particular in this case the attacker, wanted him to see. Turns out this is actually possible, but let me sort of show you a couple toy examples, and I'll show you a quick demo, and then I'll tell you a little bit about how it works and what we might do about it. So an example of a pollution attack on a search engine might be taking a result that's maybe ranked towards the bottom, or maybe in the example that I'll show you actually on the next page, and bumping it up to the top. Let me show you a brief example of this actually in action. This video is about a minute long. The user basically searches for shoes, and you can see here the search history is empty. Okay, it's not going to be empty in just a minute. But now basically what I'm going to show you here is basically the user scrolling down, nothing on the first page. Well, the result of interest is not on the first page. The result of interest here we're looking for is Macy's shoes. Okay, so there it is, shoes at Macy's. Okay, what we're going to do in this attack is we're going to move that to the first page. Okay, so the user basically now visits another site. I'll show you in the forthcoming slides what happens here, but the user's visiting some other site. Muffin, tasty, yum. Okay, now what happens is we look at the user's profile, and there's other stuff in there. Macy's shoes, Macy's women's shoes, Macy's shoes, etc. How did it get there? I'll tell you in a minute. But the upshot of this is now when the user searches for shoes, there you have it, right on the front page is that Macy's shoes result. Okay, so bad scene, right? So now we have a case where not only are there sort of all the sort of potentially bad things about personalization that we've been talking about, but also attackers can manipulate this, right? So this is sort of like SEO version. I don't know what version are we at, but the new wave of SEO perhaps. What's going on? Well, if we look sort of beneath the covers of that page with the muffin, what we actually put into that page is actually some hidden. There's a hidden iframe basically with embedded images, in embedded image tags, cross origin requests. In this case, so in this particular case, you can basically put cross origin requests. I'm showing one that's a cross origin request to YouTube. You can also put other cross origin requests, things like Google search entries, so on and so forth. So the user doesn't actually see these things. But in fact, if the user's logged in, those types of things, watch history, search, etc., are basically going into the profile, right? So the user sees that, but under the covers, these hidden iframes and things are polluting the profile. So you can basically use this cross-site request forgery and then host it on a third-party website. And if you can convince the user to go there, then jackpot, right? Okay, so I showed an example of search in that demo. It's possible actually to do this in other cases. We've also done it with YouTube, Amazon, and other cases. So I'll show a little bit more about YouTube. You've perhaps watched some videos on YouTube. If you have, you've probably seen these recommended videos, right? Well, let's say you're looking for drone strikes, right? So let's suppose that somebody decides that they want to give you a negative opinion of drone strikes. Well, what if we could basically manipulate this recommended video list so that all the videos you saw when you searched for drones were negative? Turns out that's actually possible as well, right? We basically do the same kind of attack, right? We have these fake browsing behaviors. We need to figure out how to inject them. And then, of course, we need to figure out what to inject to basically cause these kinds of manipulations to occur, which is actually where some of the fun stuff arises. The idea basically is I want to basically take this video and just jam it into the user's recommended video site. So in order to do this, right, we need to sort of solve some of these questions. In particular, we need to figure out how video recommendation works. Right? Now it turns out, so this is where I think Sinew deserves a lot of credit for basically, in particular with Google search, Bing, other places where we've managed to do this. He's done a lot of digging to sort of reverse engineer how some of these things work. I think some of the tools that we're about to hear about in the next talk may also expose some of these things. But in the case of YouTube, it was actually easy because they told us. Grad students read a lot of papers, as we know, and as it turns out, there's one that tells us exactly how the video recommendation system works. So in this case, he didn't have to actually work very hard, just read the paper, and then figured out how it worked, and then figured out, well, we could basically pollute the inputs in a certain way and then affect the outputs. So it turns out that YouTube, of course, recommends videos based on the user watch history. I'll tell you exactly a little bit about the details of how that works in just a minute, but the idea basically, again, being that if we could pollute Bob's watch history, then we can affect basically what shows up in those set of recommended videos. Now the question then is, well, we can put these fake videos in just the way that in the way that I showed you before, with those hidden iframes, but the question is basically, let me just tell you a little bit more about how we do that with YouTube. It's quite simple. You can use what's called a cross-site request forgery. The video starts to play, And we noticed basically that in the GET request, there are unique parameters for these videos. Once the video starts to play, you can actually do things like set certain things about what you think about the video. You can like it, thumbs up it, or whatever. Those are all very transparent. We can basically just forge those requests and send them back to YouTube through a hidden iframe. And then then in that user's profile, there's a history that basically this user has liked this video when in fact they haven't. The next question, of course, is now that we know how to do that, what videos should we actually inject? Okay, well, this is where sort of the knowledge of what's going on in that paper is useful, right? But basically, one of the things YouTube does is collaborative filtering. So they actually use other videos or pairs of videos to recommend videos that show up in that list. So in particular, Alice is basically going to watch more than one video, and when she watches those videos, they're basically going to result in some other videos being recommended in her injected list. It turns out that these videos need not be the same, so we need not inject the same video to get a different one injected into her recommendation list. And that's where some of the fun comes in. So basically, YouTube recommendation actually uses something called co-visitation, where it makes observations based on like what other users have done. So for example, this user basically watches these two videos or this group of videos. A lot of users tend to watch multiple videos together. So if you've watched any one in that set or any one among a pair, it will recommend the other one to you. Oh, you watched that video. People who watched that also watched this. So we can basically use those as our seeds. Okay, so we build co-visitations between the seed and the video we want to inject, and then inject the seeds. So in the interest of time, I won't go into all the details, but basically this works quite well. So what do we do about it? I think the answer there is not complete. But one of the things that we've been looking at is like, well, could you at least expose some of this information to the user? I think the next talk is a great example of something that could be used as a defense. But another thing we've built as well is something called Bobble, which is something that we've done just for search, could presumably be expanded. But the idea being that when you search for something, you get a specific set of results. But this Chrome extension that we've built also tells you other things that you didn't see in your results that users with other profiles would have seen if they'd issued the same query. So the way that works basically is pretty simple at this point. I think using a tool like OpenWPM would be a natural extension to this. But basically what we do is with the Chrome extension, we basically take the user's search term. It goes off to Google where it ordinarily would. It also goes off to a distributed set of agents that we run on Planet Lab. We run the queries all over the place, and then we give the users back some additional results, and we tell them basically where and with what profiles those results came back with. Okay, so in summary, even in the best case scenario, personalization can filter things that users might want to see, but personalization can also be exploited. And some of these old web mechanisms, vulnerabilities, etc., that we've been long familiar with as just general web security issues, now become even worse. It's time to think about defenses. Maybe there could be better verification of inputs to these personalization systems. So these types of attacks, might not. Maybe there are ways to defend against the specific kinds of injections that I showed. Maybe there are ways to allow users to clean their profiles, or maybe there are ways, things like Bobble, but better, right? Better interfaces to help explain to users why they're seeing what they're seeing. And I think that leads very well into the next talk.
Thanks. Our third speaker is Professor Roxana Jambasu from Columbia University.
It is, yes. It's hard to type. Right. Hello, everyone. My name is Roxana Jambasu, and I'm very happy to be here. Thank you to the organizers. So today I'm going to talk about my team's work and my collaborators' work on X-ray, which is a new tool for increasing transparency on the web using a new mechanism called differential correlation. And this work is in collaboration with Augustin Chantrot from Columbia as well, who's also here, as well as, of course, our student, Mathias Lecuyer, who is, has actually built this tool, so I'm speaking on his behalf. And I will start my talk with a few questions for you guys. Here's an ad that we got in one of our email accounts, okay? It's about a hotel in a particular place. What do you guys think this ad is targeting? Can you guess? Any ideas? Hard to tell. According to our tool, right, this ad strongly correlates, and I'll tell you a bit later what that means, with the presence of homosexuality-related keywords within the inbox. What about this one? Anybody guess this time?
Upper middle class.
Could you repeat?
Upper middle class. The upper class of
Pregnancy. Okay? So, hard to guess. These things are extremely hard to guess. And we have a lot of other examples, right, of, fairly sensitive topics and, very sensitive topics as well, keywords, being targeted by various advertisements. And of course, we all know here, right, in this room, that if you click on one of these ads, not, unaware that you're actually being targeted, based on these kinds of topics, you might actually leak information to the advertiser that you have no idea that you're leaking. Okay, so it's dangerous, and this is just one example, right? Ads are one of the outputs, as we call them, that are being, for which, right, our data is being used. In today's world, right, data-driven world, web services and third parties collect huge amounts of information about us and use it for all sorts of purposes. Ads is one use. Recommendations, right? We saw talk about that. Price offers, discounts, and so on. All use data about us and personalize those offers, based on that. And yet, they use all of this data without our knowledge or consent. We have no idea how our data is actually being used, right? What is it, being used for exactly? Is it being shared with third parties, and if so, with whom? And what do those third parties do with it? Can we delete it? Does it actually get deleted, when we ask it to do so? These are all questions that we cannot possibly answer as users, and unfortunately, I would argue, right, that auditors are also perhaps lagging behind a little bit. For example, FTC investigators and journalists are lacking the robust tools and scalable tools that are needed in order to reveal the data uses in a system like the web, a gigantic system and ever-changing system like the web. So the question that we have been asking at Columbia for the past couple of years, or more than that really, is there a way for us to build tools that reveal data use? For example, can we reveal which emails trigger which ads, which prior searches trigger which prices or offers, or whether Facebook shares our data with third parties and how those third parties use our data? It would be great to have such visibility, right? For those of you who are, on the technical computer science side, you may already know, understand this problem as a data tracking problem. And we know that there are a lot of, like Anupam was saying, there are a lot of data tracking systems out there. PaintTrade is one of them, just to throw, an example here. So we know very well how to do tracking of data use in controlled environments, such as a controlled operating system, a controlled runtime, a controlled language, and so on. However, the big question is, can we build such systems for the uncontrolled web, which we don't, we cannot possibly influence in any way. And in addition to this, there are a lot of other challenges with the web. The data tracking on the web, for example, the web is gigantic scale. It's extremely complex, and can we track our data, within this space? I don't think I can give you an answer on that, but we've made some progress. Okay, we've developed this tool called X-ray, which at the time when we published it in Usenik Security this year was, to our knowledge, the first tool, generic tool for tracking data at a fine granularity on the web. And it associates inputs such as emails to outputs such as ads and many other things. Its main properties are three very important properties. It's scalable. It can track many, many different inputs and explain the outputs based on them. It is generic. It can be applied to a lot of different cases. We have validated it in 3 cases, but we hypothesize that it's possible to apply to other cases. And it's accurate according to our experiments. Right now it works on Gmail, Amazon, and YouTube. I'll tell you a little bit about examples later. So how does it work? I won't go into any details, I don't have time, but at the highest level, the idea is as follows. We treat the services as black boxes, okay, which receive user inputs, such as email, searches, or browsing history, and provide user outputs to the users, such as ads or recommendations or prices. What X-ray will do is it will track some of these inputs, perhaps not all. We may not be aware of all the inputs. It will track some of the outputs, again, perhaps not all of them, and then it will try and correlate them using a new mechanism called differential correlation. So when I say that the ads, the examples that I showed you up front, those ads target pregnancy or homosexuality, what I mean is they strongly correlate with those terms, the presence of those terms in users' inboxes. So differential correlation, what is that? The key idea, right, is to correlate in a black box manner, correlate inputs with outputs. And for that, very intuitively, I won't go into details. The details are much more complex than this, but the idea is to populate a set of extra accounts with subsets of the inputs, and then use the observations of the outputs from those extra accounts to relate the inputs to the outputs. That is based on the similarities and differences in the outputs that you get on those accounts versus your own outputs, you're going to get correlation. Just to give you a very, very simple example, suppose you had in your main account, your personal account, you had 3 emails, just to make it simple, and suppose we had 3 extra accounts, to set up for this. Which consists of 2 of the emails in one account, D1, D2. In another account, you have D2, D3, and D1, D3 in the third account. And suppose you're seeing and you're trying to explain an ad that you're getting in the main account, 01, okay? It's called in this case. And suppose that you're actually seeing the same ad in 2 of the extra accounts, but not in the third account. What do you conclude based on this? Well, it's the intersection of the data within the accounts where you do see the ad that best explains these particular observations. Okay, so in this particular case, D2 is the best explanation for the ad 01. Okay, so you may wonder, well, but that sounds like a lot of accounts. How can this scale, right? I have in my inbox hundreds of thousands, I don't even know actually, emails, right? So how can this possibly scale to that? Well, we found, at the very least theoretical, we haven't gotten to hundreds of thousands yet to validate experimentally, but theoretically, we can prove that there exist algorithms that that are very scalable, and in particular they scale logarithmically in terms of the number in terms of the number of accounts that you need logarithmically for in the inputs. Okay, that is, you need a logarithmic number of accounts to explain any inputs. We implemented both mechanisms, several algorithms. One is simpler and provable, but not that robust in our experience. Another one is much more robust, but we don't prove it. Although our experiments do show the same logarithmic trend in how they grow. I won't go into the details of how these algorithms work, but the idea is that it appears that they scale. Okay, theoretically it's for sure. Experimentally, they scale, up to hundreds. Thus far, we've managed. Our details are in the Using Security paper. Okay, so we built the tool, and I want to tell you how we did it. We initially built our prototype for Gmail to associate ads to the emails that they target, like the examples that I showed you up front. And then we applied the correlation engine as is to explain Amazon product recommendations based on the wishlist contents, and YouTube video recommendations based on prior videos that you've watched. This change, this port, required 0 lines of change in the correlation mechanism. And without any changes, we were able to obtain, across all of these services, 80 to 90% precision and recall. And these are very different services. What that tells us, at least suggests, right, is that X-ray is pretty generic. Pretty generally, so we are very optimistic about applying it, in other situations. I don't think I have the time, but I'm happy to give you other examples of associations that we found. They're on our website, which I realize now that I didn't include a link for. It's in our paper, the link, and you can find it on the web. Of course, many open challenges, and I'm just referring to the challenges related to X-ray or building a tool that's generic, scalable, and accurate, right, for the web, so that we can, track what's happening out there on the web. X-ray is generic, seems to be generic and scalable, but it can have false positives. The big question, like Anupam was asking as well, is how do we design tools, that both scale and are extremely accurate, right? The second open question, right, is that how do we build tools that detect all forms of targeting or personalization and so on? Because X-ray, I didn't quite get into this, but X-ray makes a bunch of assumptions about how targeting works, which makes it very relevant for certain forms of targeting, but not for others. And finally, our system, as well as Anupam's system, views services as black boxes, but these black boxes are incredibly complex, right, with many third parties involved, right? The targeting, like Anupam was saying, the targeting in the ads could have been intentional targeting by the advertiser, some third-party effect, or an internal algorithm within Google that just made that connection. So the question is, how can we attribute targeting to particular services so that we can identify where the source of information, right, comes from? Thank you very much.
Thanks. So let's continue with discussion among the panelists. And I'd like to start by asking a question that actually is the very last, goes to the very last point that Roxana made. And that is how far these methods can go. All three of your talks discussed how by adjusting behavior and observing carefully what happens, you can either learn about or manipulate the output of this very complicated ecosystem. But we know as computer scientists that there are inherent limits to how far black box testing can go. So how much transparency do you think we can get as users? Can we get all the way to where we want to get? Can we get partway there? Let's start by talking about that. What are the limits of these methods, which are still pretty new, I think, in the research community?
So just to get started, one thing that I want to say is I expect that what these tools may help us do is highlight places that require deeper investigation. And that deeper investigation has to happen, in some cases, in collaboration with the companies like Google or other big players in the advertising ecosystem. And in some cases, it might happen through interaction with regulatory agencies who can then go in and have greater visibility into the ecosystem. So just to make concrete, to return to my job discrimination, gender-based job ads discrimination example from the outside, it's very hard or impossible even to tell. So there was a gender bit that was visible to Google there, and then the browsing history that's possibly visible to many, many players in the tracking ecosystem. What combination was responsible for the actual targeting is hard for us to tell from the outside. So that's a short, my take on this question.
So to add on, I'm sorry.
Please.
So to add on what Anupam is saying, and not replicate that, because I fully agree with that. I think that we can certainly make huge additional progress. I think that we're just at the very beginnings of building these tools. There are likely going to be major, roadblocks and walls. Which my feeling is that if we can open transparency, open a little bit the black box, then we can start perhaps requesting more transparency from the services, right? So a very interesting direction, that very long-term direction that I'm, thinking about is, what could services do to help this kind of transparency? For example, if they somehow told us, but that's, it's not going to work at a very, very fine granularity, but if they somehow, provided some information with respect to how, the data is being used, then we could potentially, that could simplify, right, these algorithms, because you're only verifying what you're told as opposed to trying to discover it yourself.
I think verification is probably more attainable, like what you're saying, because basically you can attribute causality with controlled experiments, right? So if something says, why was this recommended to you? Well, it's because you bought this before, or you had this in your search history. That's a testable claim. I think the general inference problem is much more difficult because of latent variables and things like that, right? So in addition to the confounders that we were talking about in the break, like there are things that if you just don't enumerate them, it will be tough to basically know. And some of those things we may not know what they have. So, and if you miss those or you don't enumerate them, then you may you may not be able to explain, or you may actually get a wrong explanation.
Right, which is why I think, we've been talking about tracking, data tracking, and tools to discover tracking and, data collection, who gets what. I think those should be used in cooperation with, discovering data use, because, we can keep track of what, data they have, and those could serve as inputs, to tools that discover, how what the outputs are.
I'll slightly disagree with Nick's, just to make things lively. I slightly disagree with Nick's claim that causal inference is not possible. I think with that part of your claim, I disagree. I think that even with limited observability, causal inference is possible in many cases, not always, but in many cases. And like the job and gender ads thing showed, with very limited observability, I can say that the gender difference is what caused the ad differences. However, explanations, that part of your statement I'll agree with. Explanations are much harder to generate because that requires greater observability into the system.
So I'll push back on the. I'll push back a little bit on the gender example. So I don't know if it's the case in that particular example, but the issue of like hidden confounders seems to be like something that could make it very difficult in causality. So let's say for example, just to take your example and turn it into a toy that might break it would be, you might have gender as an explanation. However, let's suppose that in fact the real causal variable is something like people who visited Pinterest or something like that, right? Or tagged a particular product, right? And it may be that women do that more than men, and you may have not accounted for that particular variable. So you might say, oh, well, the actual cause is actually this gender variable, but in fact there may be a correlated variable that's the true cause that's actually hidden, and if you didn't enumerate that, then you might not catch it.
No, but in this controlled experiment, the only difference between the two groups is the gender. There's no other difference. So the cause is the gender difference. You're right in that gender might lead to something else, some other inference, which is the basis, but that's not the point.
So I guess if you're doing it in a controlled setting,
Yes, and
then I agree with. I think I agree with what you're saying. If you're doing it with real data, then I don't think I agree.
So you can see that men and women are seeing different ads, but how that came to be might still be opaque to you.
yes,
Yes?
that explanation requires more visibility.
And you can also not say how real women, men and women see the difference, right? Because real men and women, have a lot of other things, in their accounts, which might actually result
And
in.
there is also a lot of literature on drawing causal inferences from observational data. We haven't gone there yet. It's certainly difficult, but I'm not ready to declare that it's not possible at
Yeah,
all. More
certainly
visibility would be better,
Yes.
certainly.
I wouldn't say impossible, but I think some of those techniques require lots of data, right? So I think that will be an interesting thing to see is how much data do you need to draw like meaningful
Sure.
statistical conclusions about it.
Right. Before we open it up for questions from the floor, let me raise one more topic. And that's really, I think, raised by Nick's talk, which is about the possibility of manipulation of these systems in order to get a certain result. To the extent that this kind of manipulation starts to happen, one would expect companies to try to detect or prevent the manipulation, right? By seeing cross-site requests that look certain ways. And this gets us to the more general issue of countermeasures from the companies that are implementing these mechanisms, because you could imagine that they are trying to change the behavior of the systems in ways to make them more harder to characterize, harder to measure. Could you talk a little bit about to what extent that might be possible and what happens if it starts to occur?
I think there are different types of countermeasures you could imagine. I mean, certainly there are countermeasures involving mechanism, so and also process, right? So the first place you might imagine a countermeasure is like in that first initial input, validating that input. So there are ways that I think you could do that. For example, attaching certain tokens to a cross-site request or something like that. And I think I'd want to think about how to do that right, but I think it's possible. Then, as far as the process, like as Google is, or whoever, right, the recommender system is processing those inputs, detecting anomalous patterns might be another place where countermeasures might come in. And then on the user side, there are, I think, a lot of interesting potential countermeasures as well. A tool like Babel that can show you alternative results is one type of countermeasure. And I think basically there's some real challenges because the user has to know and care to look. And figuring out how to present that in a meaningful, unobtrusive way, in a way that a user is actually going to understand and know what it means and care about it is a real challenge as well.
I just wanted to add that potentially from a transparency perspective, so the big problem is that the user, a website is doing actions on on another service on behalf of the user without the user's knowledge. So if you can inform potentially the user that he's actually being targeted based on data that they haven't actually typed in, right? And you can perhaps track that. Then I think you have a way of at least identifying potentially you may have actually even a way of identifying the site that issued those requests on behalf of the user that weren't actually typed in.
Yeah.
What happens if a site or service tries to detect experimental tools like yours?
Mine breaks. Ours breaks. They can. So they can detect it, and right now we do not have in our version. We do not have defenses against malicious services. We do have defenses, or we do act very carefully so that we are not detected by other types of defenses, not against us, right? But services employ a lot of kinds of defenses for their own good. I think that there are ways to make these tools much more robust, and we are certainly discussing those ways.
So just to add to that, we haven't also actively encountered that kind of activity yet. But one thing to do, and I think Arvind mentioned that earlier in the morning, is to try and simulate real users. Right now, the profiles are somewhat artificial. You could either simulate real users or crowdsource. Those would be some initial steps.
Sure. Okay, let's open it to questions from the floor. I think David had his hand up.
So thank you for doing whatever I'm doing. Thanks for a really interesting panel. I just wanted to offer some observations and seek some reactions on what we've been seeing in Washington when working on some of these issues in terms of targeting and discrimination in the online context. So I'm working with civil rights groups that are increasingly interested in these issues and that have been in a series of conversations with policymakers about what might be going wrong and what to do about it, or preliminarily how to detect it. And so firstly, we've sort of said, where we've ended up is you can try to correlate things and say, well, as far as we can see, it seems that women are generally seeing different things than men, but that's not been quite enough in the policy setting to really actuate policy responses to potential discriminatory activity. And policymakers say, can you really tell me definitively that the protected status, the race, the gender, the age of a person is causing this difference? And our answer has basically been no, and they say, well, is that on the horizon? And our answer has basically been no, it's not on the horizon to be absolutely certain that no confounding factor, which is not a protected status, alternatively explains the observed difference in what actual people are seeing. But I'd be very interested if, in your opinion, we should revise that impression. And part of the reason, to follow up on what Ed said, part of the reason that we've ended up in that place right now is that we have seen, even in our own just slight probing, in particular of credit card offers being targeted online. There was one actor where if you open the JavaScript console of your browser while you have the page open, and I guess it's if the console's open while the page loads, it echoes something out that says, oh, we notice you have your console open, so we're not going to target anything to you. And what this appears to be is an upshot of the problem of click fraud, where for reasons completely unrelated to research or civil rights, many of these actors have a strong incentive to differentiate automated page visits from human ones. And in fact, there are startups, as you may be watching, that specialize in such detection. And so what we basically said to policy folks is that the analogy from the offline world of sending testers in, which is really, I think, what a lot of policy folks would like to see. You know, you send a black and a white person with the same credit score into a bank branch to get a mortgage, and if they walk out with different offers, that is strong indication that there may be a problem where two people rent, and when one goes in, there's not an apartment available, and when another person with similar qualifications but different protected status visits the same rental office, there is a place. I mean, those are the sorts of things that are the building blocks that have been, in the offline world, the building blocks of these discrimination claims. And there's tremendous appetite for similar factual predicates coming out of the online world, but thus far we really don't see that on the horizon. So I wonder whether you think we should be more optimistic, or otherwise whether you've thought about ways of perhaps working with regulators to sort of help them to articulate questions in settings where regulators might be able to get more information than an outside observer, can get directly.
So I think these are very good examples, and the last comment that you made, I think, is going to be an important part of how the solution has to come about. And I think the jobs and gender-based experiment that I showed you, these controlled experiments, could be the trigger for a deeper investigation, and that is how we might be able to establish causality. Let me also mention one other study from Carnegie Mellon that Alessandro Acquisti recently did on hiring discrimination. And in that study, what he did was, similarly, it was a controlled experiment, but he had It was a combination of digital world and physical world, where he actually created a bunch of fake profiles on social media. The experimental and control groups differed in one characteristic, like religion. And then he sent fake resumes, which were identical to all these companies that were looking to hire. And then he measured the statistical significance of the difference of interview calls, and found that there was a causal effect between how indicative, for example, the religion of the picture on the social media page was with the interview call rate in some parts of the country. So this was a controlled experiment, but see, this is actually showing a causal effect that has implications in the real world. So I think that there has to be a combination of these things. The other, and this is not an objection that I have got today, but it was an objection that I have heard in the past to these kinds of controlled experiments, is, oh, but the users that you're simulating are not real users. Perhaps the entity you're studying would treat real users differently. However, if they're treating fake users in a discriminatory way because they know that these are fake users, that seems highly, highly unlikely. So the control experiments, I do think, has to be an important part of how we approach this problem, if we are to expect to show causal effects, which is not such an unreasonable expectation in this domain.
So can I just have a follow-up? Oh, Nick, did you want to come in? Go ahead.
I actually wanted to just ask a question back to you. Your question kind of reminded, I mean, it made me think a little bit about the discussion we were having before about confounders and causality. And you were saying, well, you might not be able to, like, with certainty, say that the cause of this decision was because of this protected status. But supposing that you weren't able to definitively say that, but you could say that, well, it was perhaps because of these other confounders. Well, does it matter that you can't distinguish the two? I mean, perhaps this organization or entity is they may not be using the male-female bit to make the decision, but if they're using these other things, these confounders as a proxy for that,
So
is
legally,
that
I think
protected?
it matters
To
a
what
lot.
extent is that protected?
Yeah, legally it matters a lot.
In short, sadly, yes.
Okay, yeah. I mean,
Not
because it seems like a huge loophole.
Which is
yeah.
yes. Which is not to say that you couldn't have a discrimination claim be successful if it was based, e.g., on 95% of Pinterest users in a toy example. So, right?
Yeah.
So imagine a world in which, I mean, let's say you're recruiting for, a technical, job, and you think people who use Reddit are apt to be good job candidates. Let's imagine it's not Reddit, but Schmeddit, of which 99%, as opposed to whatever actual high percentage of the users are men. If you recruit there and end up with a, even more male-dominated pool than you otherwise would have, that kind of disparity or something analogous to it in some other targeting context can sometimes be enough to create a legal challenge, but certainly you are in a much more challenging world than if you're able to show that the actual protected status was the direct cause. And it gets metaphysical too, right? Well, right, direct cause versus, but it does, what you want if you're trying to find your ideal, easiest intervention, what you really hope for is something that is direct in terms of its relationship to, I guess the term is protected status for one of these categories.
It just seems like the natural loophole is to just, as soon as that becomes the norm, everyone's just going to jump through the loophole because it's probably not that hard.
So just to follow up on this very quickly, I wonder if there's also value in describing for a non-technical audience the challenges of actually producing the kind of evidence that they want. So, and being able to say, like, there are very practical and technical reasons, even legal reasons actually, which we'll probably get to in the next panel, why it's very hard to generate the evidence that it seems to be so in demand. And explaining that, rather than just making it part of, like, the description of the technical project, can actually be enormously valuable to the debate. So I wonder if there would be a possibility here of doing that kind of work also.
So
Please.
Does someone want to try and talk about how you can tease apart correlation and causation by careful methodology? Or is that just a graduate course?
So I was not thinking of answering that question. So if someone else wants it, that'll take me longer. But I was going to add just one comment to what Solon just said, which is maybe what we should be after is not just looking for differences based on that one gender bit, but on a set of attributes that are strongly correlated. And then we can argue, however, just showing correlation between that combination of attributes and the discriminatory action is not sufficient. There we should try shoot still for causal effects. Now, so that means that instead of just showing that the gender change in the gender bit caused the discriminatory action, we should argue that this combination of things, which includes not just the gender, but maybe some aspects of shopping habits, some aspects of something else, which are strongly correlated with gender, that combination causes the discriminatory action. And that, I think, is likely to be more feasible technically to do, even with real data from observational studies rather than controlled experiments.
Does anybody have an easier question?
Yeah, I have an easier one to Professor Jambasu. That you were talking about a black box. That was a black cloud up there that you illustrated. Maybe we need that terminology.
I put it in a black box. Yeah.
But if I can summarize this conference so far, is that it is a jungle out there, and that there are black clouds hovering over the rainforest at all times.
Yeah.
I have a question. Suppose that a company involved in one of these businesses that involves adjustment or personalization based on behavior wanted to be proactive about transparency about their algorithms. What could they do without giving away the store from a business standpoint?
This is, so all I'm going to say is that I don't know. This is something that we are thinking about, but I don't think it's clear because there are always trade-offs. So if they release, if they're very transparent, then they release internal information. For example, imagine that Google, showed for every ad, showed exactly what that ad was targeting. You can imagine a lot of competitors coming in, observing that, right, and potentially reverse engineering their algorithm, which is their very valuable secret sauce, right? Similarly, right, I think that there are attackers, potential, optimization, right, search engine optimizations and attacks like this, right, that may be very much, improved, right, by transparency. So my feeling is that there is a level of transparency, right, that certainly needs to be added when we are seeing ads that strongly correlate with, cancer or Alzheimer's, or which we've seen, for all of these examples, and the user has no idea that that's how, they're being targeted. They're exposed to various privacy threats. And so I think potentially for those kinds of topics, right, or those kinds of, of targeting, maybe, it's worth adding transparency. But that's just one thought. I really don't know what to answer.
Your question was pretty easy until you got to the last part about giving away the store or whatever. And but I think
you can answer the easy version if you prefer.
Yeah, no, maybe. I think because I think it's hard to tell what gives away the store. But I think anyone who's sort of like played with these algorithms from the other side, like in other words, done anything with machine learning, knows that basically it's not just the inputs that basically generate the magic. It's basically figuring out how to like represent the features as well as how to weight them, as well as what algorithms to use, and basically, just identifying the correlations is maybe step one, and then there's a lot of pain. So it could be, and I think there's a question of who do you need to convince that they're not giving away the store, but it could be possible for many of these entities to divulge we are making these recommendations based on this set of inputs, and because you did X, and you see a little bit of this in Netflix and Amazon, like we're recommending this because you watched this or you bought that. You can imagine expanding on that a bit, maybe without endangering the secret sauce, because if the secret sauce is the algorithm and the weights.
Sure.
But it's, may I just add, just in response to this, so it's the secret sauce of Google, it's also potentially the secret sauce of advertisers, right? Who themselves, have their own ways, right? So for example, you figured out a particular campaign that works extremely well for you. If your competitor suddenly, you've done a lot of effort, right? And then your competitor, right, can find out how and then imitate, become better, and so on. So it exposes a lot of I think secret sauces that are, that are hard to understand exactly where to draw the balance.
Yeah, but I guess to be concrete about that, I mean, I could say that I'm marketing something to you because you're a female of a certain age living in New York City, but I don't have to tell you that actually, the fact that you're living in New York City is really not that consequential to the fact that I decided to market this to you. So the weights, may be something that I keep private.
Right. I do want to say that Google does offer some information. It's very coarse-grained, in my opinion, too coarse-grained for some of the types of, of the targeting that we've seen. But they do offer some information if people want to look at how ads are targeted in Gmail, for example.
Yeah.
So keeping the secret sauce part aside for just a minute, in machine learning, there is a lot of work on interpretable machine learning algorithms. These are algorithms where you take as in maybe you did 10,000 things and then you are shown a certain ad and you don't know which of those 10,000 things actually caused the ad to be shown. What interpretable machine learning algorithms try to do is out of all those 10,000 things, it tries to produce a sparse representation of maybe the 15 things that actually has the highest influence on why you might be interested in this ad. So that's a step forward, I think, that would be really useful.
So what happens if the particular scenario we're talking about is like one that often happens with ads, right? One way an ad service could work is that the ad service knows some information about the user, and they know something about the page that the user is viewing, and then they just hold an auction where advertisers are bidding based on user characteristics or based on keywords. And whoever bids has submitted the highest bid will win the auction, or some sort of weighted algorithm based on bids. The point being that which ad you see is not chosen by any one party, it sort of emerges from that automated marketplace. Is it harder to follow, to diagnose, understand what's happening when it's the output of a market process than if it's just the algorithmic policy of one company or a model built by one company? There's a sense in which no one may understand exactly why you got the outcome you did, because each company each advertiser might know why they submitted the bid they did, and the marketplace may understand who had the highest bid and what everyone else bid, but nobody really knows. What can you learn by experimentation in a situation like that? I mean, you can see outcomes, right? Because the Gmail example is like this, I think.
So in the Gmail example, the only data that existed in our accounts was the Gmail data. So the only entity that had any data about our accounts was Gmail. Okay, so it couldn't have been other parties that that used our data.
So in your example, Google was holding an auction based on the words that were in the message.
In the message.
Right.
They must have been in the message because they were nowhere else, or in our profile potentially, right? But that's it, because there were no other actions that these users made.
So when you see words associated with pregnancy in the message, then certain ads tend to come up, right? And from that you can infer that those advertisers bid more, or Google thinks there will be a higher click-through rate on those ads.
And we have no idea which is which. We only do correlation. What I would say is that in the real world, where real users actually have a huge amount of other kinds of kinds of activities. And many different parties have data about them, and many of those parties participate in the auction. That is a much harder world that we cannot say anything about right now. But it's very interesting, to study.
I think there is also an opportunity here for exactly this reason. Because since in this case, on this platform, Google is trying to decide on what keywords various user groups can be targeted. If there is consensus on specific harms that as a society we want to guard against, like targeting jobs based on gender, then that could be enforced at that point. That on the ad exchange, you cannot bid on certain keywords, on certain interests or characteristics for certain types of ads. And to some extent, that might already be happening. So, we have looked at Google's policy. They say things like, for retargeting of ads on sensitive topics like health information and so forth, they should not be done. It's not clear exactly what they mean by health information, but at least I see some reason for optimism here that companies want to do the right thing.
So an ad network could hold back information, not give it to the bidders, if they think that information might lead to a result that is undesirable.
I don't have any answers there, but I do wonder if you could get some better control over these experiments by perhaps bidding on ads yourself. Yeah. Yeah.
What did they find?
Junie.
So what did they find?
I don't know enough to say.
Junie.
Yeah, I just wanted to say it. I think you asked the perfect question, because as programmatic bidding becomes more and more the way of advertising, then it becomes incredibly complex to determine what caused a particular ad to be served. I also think Solon really put his finger on it, because there are proxies that may correlate and actually affect protected classes. There are disparate impacts that result from these kinds of things. But how to tease it out and how to deal with causation is what I'd really like to solve for, and I don't know how. Also, to be able to see when data is being transferred to lead generators for purposes to target vulnerable populations. These, I think, are some of the most troubling issues. And it's not, I would distinguish between an offer and a determination, or the differentiation based on protected class that will limit eligibility. Like I thought your example of gender-based ads were exactly right, because that's not something you can go out on the web and search yourself and get different results. That is something that you, and I will speak for myself, as a woman, I can't change that. I can't go out and look for the $1.27 stapler. So I hope you can make that research work.
Back in the setup.
Thank you. Thank you for the great presentations. I want to follow up with two questions. One is, what happens, as Anupam suggested, if we don't talk about, women of color, pregnant, single mom, whatever, but instead have these kind of weird categories, which turns out that they're constantly, as surveillance studies scholars have called it, get sorted out, right? Like they get kind of discriminated. How are we going to have this discussion? I mean, maybe it's a hard question to ask computer scientists, but how can we kind of discuss these categories that we do not socially categorize, do not socially recognize, but they're definitely correlated subjects that are discriminated. And the second one is a kind of bridge between the first panel, where all the speakers propose obfuscation as a kind of possibility, or at least they touched upon it as a countermeasure. And if I read Nick's presentation with respect to countermeasures for cross-site request forgery, it was detection of anomalies, which you could actually say obfuscation detection. So I find it very interesting that in one day we're talking about privacy and possible measures, and in one we propose obfuscation, and in the other one counter-obfuscation. And I'm just wondering how we can deal with these translations to technology and how we can distinguish and protect them. Thanks.
So on your first question, and I'll leave the second one for Nick, is that as we design machine learning algorithms, we can take into account input. As we design machine learning algorithms, we can take into account input from philosophers and social scientists and others who think about this problem of what type of categorization and what type of targeting should be disallowed. Typically, machine learning algorithms just optimize in this domain for click-through rate or revenue, but you can design them subject to the constraints that certain types of values are respected, like targeting will ignore some types of information. The decision of how to come up with these categories is in your hands. So I put the question back to you.
For the second question about obfuscation, I think one of the things we could think about is, in terms of a tool like Babel, the data that we could get out of that we could use quite constructively for certain types of obfuscation. I mean, I think that a lot of the obfuscation we were hearing about was like, let's throw up basically a firewall and sort of make sure that this data like never leaves my possession and I can't be tracked and so on and so forth. But with controlled experiments, like of the type we've been talking about on this panel, one might discover other kinds of positive effects. For example, there may be equivalence classes of groups where maybe I don't need to totally obfuscate everything about me, but as long as I can fuzz it enough so that basically it's clear that this is not me, but I'm in this equivalent class of users, maybe I can still get, results that I find relevant or personalized or whatever, so that when I search Natural History Museum, I don't get the one in London, I get the one in New York, and yet I'm still not tracked. And I think the types of tools that we're talking about on this panel could be used in conjunction with controlled experiments to figure out like how to do the right kinds of obfuscation. So maybe there's a sweet spot.
And another question about Babel. Sounds like a great tool, and I can't wait to give it a try. I was wondering if you could talk about the curation of the profiles that you're passing the search results through, both technically and kind of socially. Are you choosing certain socioeconomic type of profiles, gender, and other qualifiers for that?
We haven't really done too much in the context of sort of curated profiles. Everything we've done pretty much is with logged out users without cookies. I mean, everything we do in the tool that runs, like so when you run it, those would not be compared against specific user profiles. Pretty much everything that's going on in the tool that's out there that you would use is geographic, which is fairly, I guess you might say, one step of the process. I think you raise a really important question, or a really interesting question, which is how to basically generate profiles, meaningful profiles to compare against. And I'm not sure what the answer is to that question, but perhaps, again, like if, gaining some insight from tools like X-Ray and AdFisher, we can maybe figure out, okay, this is a particular profile we want to generate. We did a little bit of that for the paper, so there's some data about, what types of profiles, see more personalized results in the paper, but the tool itself doesn't do that.
Yeah, I'll just add, because I think when people who are searching see that difference, then you can understand that it is a form of surveillance. You're being watched, and modify your search results based on that.
So actually, that was one hurdle, was basically, okay, what profiles do we generate? So perhaps some of these tools can help with that. I think the other that the OpenWPM thing may help with too is like generating the profiles is a huge pain in the neck. So And then you have to curate them as well, right? Because as soon as you issue searches with those profiles, they're polluted in some sense. So that's a tricky problem.
Thanks.
Anyone else? Down here in the front.
Yeah, I'm wondering about iatrogenic effects of excluding information based on protected classes. Because once you ignore some information, if it is in fact meaningful, then when it re-optimizes, you're going to have weight on things that really don't matter. So for example, if you're not allowed to consider whether someone smokes, and you do an analysis of what causes cancer, you might end up finding out that being European causes cancer, which is, which is not.
Yeah, so that's an excellent question. So I think as a society, we have for a long time agreed that certain types of information we will simulate ignorance of when we make certain kinds of decisions. In particular, using gender for hiring decisions is one of them. So that's where I'm not suggesting that the optimizing machine learning algorithms simulate ignorance of arbitrary attributes. But this is a place where computer science has to take help from people who are legal scholars, philosophers, who have some understanding, and there is societal consensus on many such things, that certain types of information will not be used in certain kinds of classification decisions. And the simulation of ignorance will have to be with respect to only those attributes. So it's going to be very task specific. And that's something that we have done, and Solon probably has more to say about that than I do.
But if I can have a follow-up question. So I wonder too if the computer scientists can teach lawyers something. And so in particular, the idea that we can have these discrete categories of information which are prescribed, then everything else is fair game, when in fact what some of the research you might be doing reveals is that that's a very naive way to actually approach the problem of unfair outcomes, unfair treatment. So I wonder if you thought at all about how your research might inform the legal debate about fairness rather than it being the opposite direction.
Right. So I think not specifically my research, but let me mention some work from Cynthia Dwork, Moritz Hart, Richard Zemel, and others on fairness through awareness. This is a paper on fair machine learning classification algorithms, and they address a specific thing, which is about these proxy attributes. So gender, just simulating ignorance of gender may not be enough if what you're trying to protect is gender-based discrimination. So they have this notion of a distance metric which takes into account other attributes that might be strongly correlated, for example, with gender. And then they want to say that two individuals who differ in this way, not just in the gender bit, but in this way, should not be treated differently. So that's an example, a concrete example of where computer science is beginning to push a little bit beyond what is standard in the law.
May I also offer my perspective a little bit on this? I think that definitely there needs to be a communication between computer scientists, right, and legal parties or philosophers, right, who can think, right, have the background to think about what's fair, what's not fair, and so on. One thing that we can offer certainly, and we are hoping to offer, is information about what's happening, the kinds of new types of discrimination that might exist out there, right? There's clear categories of discrimination that everybody kind of understands in conjunction with the uses as well, that they're not okay, right? Like Anupam was saying. But for example, what we found was another form of discrimination, which I don't know if it's if it's right or wrong. It's not for me to say whether it is. So we found, for example, that in a lot of cases, we found a lot of ads that strongly correlate, that were advertising for loans for used cars, subprime loans for used cars, that is, those kinds that offer 100% acceptance rate, that strongly correlated with the presence of keywords such as being broke, kind of having huge debt, or needing a loan. Okay, and those seem to me, right, to like subprime targeting, right? They seem to me to be, these ads, right, seem to target users with financial, difficulty, potentially, to sell them even further, more riskier kind of financial products, right? So that to me seems to be a I don't know if there is actually, I cannot confirm that there is a discrimination because our experiment, that particular experiment cannot confirm that, but we did see strong correlation with a lot of different ads of this sort. So, is that okay? Is it not? I don't know.
So coming back to the question about the effects of removing certain features, I think it's also worth sort of teasing apart training and testing of the algorithms, right? Or to put it differently, what can be known versus what are you allowed to make decisions on, right? So certainly an employer can know that you're male or female, but is not allowed to make a decision on that. So there's a question about, what information do I have, and what am I allowed to gather versus, or what am I allowed to infer, which I think is just like an unsolvable problem, right? I mean, even if I say you can't gather this information, guaranteeing that it can't be inferred is basically, I'm not going to say impossible, but probably impossible. Okay, so now what can you do given that you can't prevent certain things from being learned? Well, I can run a machine learning algorithm and figure out, well, actually smoking is basically a good indicator of whether or not you're going to get cancer, and I can know that, right? Now, can I make my decision on it is a separate question, right? So I can train my algorithm super well, but when I run the algorithm, now I'm not allowed to use that feature, right? Now, where can computer scientists help here? Maybe if there's additional transparency that says, well, we made this recommendation to you about insurance or treatments or whatever because you're European and male and you buy X, Y, and Z, and now we can say, well, there's a correlation between those things and smokers. Now, is that legal or not? That's maybe not for us to say, but we can at least establish those, those correlations.
Great, thanks. I think this last question and discussion are a perfect place to break because they look ahead to the next panel, which is on measurement, policymaking, and enforcement. We'll take a 15-minute break, and then we'll come back for that panel. Please join me in thanking our panelists for being here. That was great. Thank you.